This meeting is being recorded.
Okay, so what is a linear differential equation? Let's understand the two forms of a linear equation. The general form is dy by dx plus py is equals to q. And what are p and q? Where P and capital Q are functions of x. They are functions of x only. Right? And if I swap x and y, I will get dx by dy plus px is equals to q. This is also a linear differential equation. But what is the difference? Now the p and q, they will become functions of y, fy or gy. Or they can be constants also. They are either functions of x or functions of y, depending upon the first type or the second type, or they can be simple numbers, simple constants.
Yes.
So can we have an example of a linear equation? Dy by dx plus y is equals to, let's say, cos x. What is p here?
One.
Yes, p of x is 1. And what is the q function?
Sir, cos x.
Cos x. Now let's try to see how do we arrive at the solution of it. Can this be converted into a variable separable form? That comes to the mind.
Yes, right.
Can we separate the variables in this equation?
No, sir.
No, it is not possible, right? So there should be a different technique. There should be some way to find the solution. And that's what we are going to discuss, because it is not variable separable. To solve such equations, the first step is find something which is known as an integrating factor.
Yes.
Find the integrating factor. And what is an integrating factor? Integrating factor is nothing but e to the power integral of p with respect to x. Now, what is the integrating factor will be here? What is p here? 1. So we find out e to the power integral of 1 dx, which is simply e to the power integral of dx, and integral of dx is x. So first step is over. We got if, which is the short form of integrating factor, is equals to e to the power x. Right? This step is clear.
Yes, sir.
Right? But the one important thing to note here is whenever we find out the integrating factor, we are integrating in the power of e. Right? So we omit the integration constant.
Okay, yes, sir.
There is no need to put the constant of integration. Omit the constant of integration. Right? So without that, the integrating factor is e to the power x.
सर ये वाला एक बार फिर से एक्सप्लेन करना है ये वाला.
Okay. So integrating factor की definition क्या है? Integrating factor is e to the power p dx.
Yes, sir.
E is our the base, the common base, e to the power integral of p dx, and p is whatever we get from the equation. Here p was 1. So for this specific equation, the integrating factor is e to the power x. Right, now the second step is to write the solution, and the solution of this equation is given by y into integrating factor is equal to integral of integrating factor times q plus c. Just learn this formula. The solution of the equation will be y into integrating factor is equals to integral of integrating factor times q plus c.
Yes.
Okay, then now let's apply this formula. If we apply this formula, our solution will become y into what is the integrating factor in this equation? E to the power x is equals to sine of integration. Integrating factor is e to the power x. What was q in this equation?
Cos x.
Cos x e to the power x into cos x dx plus c. We only need to solve this integral and we will get our answer.
Yes.
Now, in order
Sir,
to solve such integral, we will have to use isolate.
Yes, sir.
So
So
cos
pehle
x will
cos
become the
x.
first function, this will become the second function.
Yes, sir.
Let's do it separately. Let's consider I is equals to e to the power x cos x. And let's apply integration by parts. Cos x is first function, e to the power x is the second function. We get cos x integral of e to the power x minus sine of integration derivative of cos x, which is minus sine x, into e to the power x, which can be written as cos x e to the power x plus integral of e to the power x sine x. We'll have to integrate it one more time. Cos x e to the power x plus. Again, sine will be the first function and e to the power x will be the second function. So it will be sine x into integral of e to the power x, which is e to the power x, minus sine of integration derivative of sine x, which is cos x, into integral of e to the power x, which is e to the power x, which is equals to cos x e to the power x plus sine x e to the power x minus I. And I plus I becomes 2i is equals